Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to try and understand the edge to data center problems. Today on the episode, it's just me talking to you about things that I've observed, talking to several of our customers in the public sector about the edge to data center and the common problems that we're seeing throughout their edge to data center architectures that they're working through. Let's first start by looking at what it means, this edge to data center. How do we arrive in the situation that we're at today? When we start talking about putting capabilities out in mission, especially in Department of Defense, but we see this in the VA hospitals, we see this in Department of Homeland Security, the FDA, FEMA, where I have devices, smart devices now that are out in the field. I need to somehow get that data so that I can use that data reliably and as quickly as possible. So how do I get that data to ground stations, to regional data centers, or back to the enterprise data center where I can run big analytics flows and AI workflows and into the hands of the analysts so that we can make some valuable business decisions based off of that raw data that I'm collecting out. What role does public cloud have to play in all this as well? There's a lot of moving parts in this. So today we're going to discuss those moving parts and how we can kind of conquer them and, corral them in. So first, let's start by taking a look at traditional IoT architectures. Now, IoT's been with us now for quite a while, and there's been a lot of promises around IoT, especially with the emergence of 5G and better connectivity out at the edge. But guess what? The edge devices themselves have become more sophisticated. We're gathering more and more data than we could ever throw 5G at. So our hopes of 5G conquering all the data and making it available seamlessly back to the data center aren't there because the IoT devices have become so powerful themselves. But we've got to figure out, how do we get value out of all this data that we're collecting on the edge back into the hands of people that can make decisions? And whether that's the decisions are being made at the edge or even back into the data center. So we're going to go look at one of the original architectures around IoT, which was done by Cisco. Now, Cisco came up with this idea of a fog. And the fog idea was that the data center connected the fog to the edge devices. So some of the processing and connectivity is happening in the fog. And this is a really good idea, especially if network connectivity, and Cisco is a network company, so they're going to focus on network connectivity first. If network connectivity is reliable and consistent, this works really well and has enough bandwidth. As I mentioned before, it doesn't work very well for us because the amount of volume of data that we are generating at the edge is just outpacing any bandwidth that we can throw at it. And what we've seen with IoT is we don't move all the data up. We only move a portion of it up to the data center where we're collecting real value out of the data. So data value is only happening in the data center still. We haven't really pushed out to the edge. There are some of you out there that have already done this and you have some value at the edge. That's great. But a majority of people are still get all the data from the edge devices, bring it into the data center. I can run my analytics, my AI jobs, whatever, my applications, whatever I need to up there. Problem is, big data being pushed up to the data center, can't store it all, can't ingest it all. It's a problem. Even pushing it into the cloud is another option that we've looked at, but even the cloud can't consume all the data that we have sitting out there on the edge. So this is a real problem. So we want to move away from moving all the data to the data center and collecting all of our value in the data center to a model that is more push the data value as close to the edge as possible and decrease the amount of data volume coming back up into the data center. Now, not all of the data value can be pushed out to the edge. I have to correlate between different edge devices to find out what's going on in like a scene graph, for example. If I'm monitoring a shipyard or monitoring a base or a facility, there's several different edge devices involved in correlation. I understand that. That value has to be in a more centralized place, not necessarily the central data center, but maybe in one of these intermediate fog or regional or building data center, right? The key here is we want to move data intelligently, not all the data, and push data value as close to the edge as we possibly can. In doing so, we can react much quicker to the edge. If I do become disconnected for some unknown reason, I can still perform the things that I need to at the edge as well. So this is where we want to get to, but we got to come up with a way of doing that in a repeatable and sustainable manner. So let's take a look at some of the things that we need to lay down first to overcome some of these problems. The first thing that we need is something called a common physical layer. This means that it's common from the data center through the fog layers down into those edge devices. We need to understand that there's one way to manage and control those devices, and that I can reliably get data off of those devices in a common way. That's why we need this common physical layer. Now, it doesn't mean that everything has to be the exact same machine, right? It just means that there's a minimal viable device that's out there that I need in order to perform all of the operations that I want to. For example, having a common operating model so that when I say I need to reboot something, that it knows what that means, right? Or I need to update it with a security patch, that I can do that in a consistent manner. So having a viable device with a common interface for this common physical layer is very important. Another really cool thing that you can do with the common physical layer is if I write my code for my application, it could run anywhere in this ecosystem if I'm using a common CPU or common GPU, FPGA, any kind of accelerator, as long as I have some way of describing that and that I can easily drop code onto those devices. There's some great technology out of Intel for this, like One API, that does a lot of that work for us. So I can write my code once, compile the binaries for the different types of devices, push that down into this common physical layer, and it's running appropriately. So the benefits from the common physical layer is common operating model, common security model, and the write once, run anywhere mode of operation. The next thing we have to look at is a software-defined infrastructure. Now, SDI has been around for 10 years, well-defined. This applies to in the data center with private clouds, in the public clouds with their virtualization, their software-defined APIs, very common. When I say a cloud instance or a compute instance, it means the same on all of these things. Pushing that all the way down into that common layer, into the edge, having software-defined infrastructure in the edge is also a very important part of this. What I get with this is I get some common ways of moving data because I have that software-defined infrastructure. I can provision resources in the edge, in the data center, wherever I want. I can move data this way in a more seamless manner, and I have a single management pane of glass that I can. Now, the next thing that we have to look at is how do I manage my data? Now, this has been a big problem with Edge, right? Right now, everyone just does a copy. I'll just copy the data or move the data up to the data center. We want to be more intelligent about this. We want to move data only where it's going to be processed. Well, that could be staying on the edge. It could be in a regional data center or up in the cloud, all those things. So we need a distributed information management layer. So I'm doing intelligent movement. I'm classifying my data appropriately. So I'm making sure that I'm cataloging, I'm reusing. I'm also making sure that I'm fitting in compliance and security requirements that may exist. So these are important aspects that I must deal with around the distributed information management layer. The benefit of this is I can start pushing less data up into the data center. I'm not moving as much data, and I'm pushing value down to the edge as much as I possibly can. But in order to really push things down to the edge, I'm going to have to somehow deploy applications out to the edge. This is where your service management layer comes in. This is what we would call today a container ecosystem, right? I'm going to push microservices out to the edge, in the fog, in the data center, in the cloud, wherever it may be. This gives me the agility to do this in a repeatable manner, portability across the whole ecosystem, and reliability. If a regional data center goes down, I don't have to rely on that in order for my service mesh to continue to operate. I have a mesh that can handle for that reliability that's built into the service management. Right. That's just an example. Another thing that we have to look at is services by themselves don't make an application. They don't provide capabilities. I need the application service layer. This coordinates the different applications together so that I can create workflows that really is what generates real business value from the data. Just moving the data around or running it through an analytics engine isn't good enough. I have to move that data from the analytics engine to an analyst workstation, whatever the case may be. This is that application service layer that I have to deal with. It handles workflows. Tools in this area would be things such as RPAs, robotic process automation, DevOps, development, pipelines. This is where I can really enforce security and compliance at that application layer, not just at the data layer down in like the distributed information management layer. So this is a very important layer that we need in the architecture as well. And last but not least for sure is the twins, as I call them, security and identity. I had these together originally, but really they are separate. Having identity in a edge to cloud architecture is extremely important. Not only on the identity side for understanding who's accessing what, but understanding what's accessing what, meaning what applications and services, what devices are accessing what data at what time and where. So we take identity beyond the typical user and place it on applications, identity of data, identity of edge devices, fog devices, data center, cloud resources. I need to be able to establish that identity so I can have compliance and security. I can have trust. I can establish trust between different entities that are properly identified. And that's a key aspect of that identity aspect. Another thing that we have is security. The other side of the twin of identity is security. This is detection, remediation, encryption, and establishing that root of trust. This brings me reliability, trusted data, and compliance. And I can truly now push as much intelligence down to the edge as possible and get really valuable, intelligent data out of the edge that's then populated up into the data center. And I'm not moving massive raw amount of data. I can move only the data that I need to in a secure manner into the architecture. Now, all of these different elements are needed in order to have a successful edge to cloud architecture that's repeatable. I've seen this several times where I have several organizations when they deploy a new capability into the theater, what I see happen is they build purpose-built edge to cloud architectures for that one application. And what I find is they sometimes get stuck. A lot of times with the data part, they say, well, and they end up hard coding the data residing in the edge. We will always process on the edge or in the data center. For this application, we're always processing in the data center. That brings up a lot of rigidity, and it also increases the amount of time it takes to deploy these new capabilities and these new applications, right? We're talking years instead of months. If we take the learnings from doing these application deployments in edge to cloud over and over again, and we start generalizing some of the things that we've done over and over again, you'll quickly find that they'll fall into one of these buckets that we've identified: the physical layer, the software-defined infrastructure layer, service management layer, the distributed information management layer, application layer, or security and identity aspects. You can find out a lot more on this by going to our blog. There's a paper written about this high-level view of this architecture of edge to cloud. And we're not prescriptive on what fits in those boxes, but understanding the key use cases that are fit in those boxes is what's key. For example, when I talk about identity, I'm talking about your typical AAA identity: access, authorization, authentication, and then key management, and uniquely identifying all of the entities in the architecture of the edge to cloud: people, devices, applications, data, whatever it may be. And then on the security aspect, we've already talked about it. Remediation, encryption, detection, root of trust are in those. And then each layer also talks about the different types of services you would find in those layers, right? How to implement those is where things get interesting, and things can be unique to the types of applications that you're running. Ideally, though, you would like to find some commonality between all the applications and services, so you're not recreating like the software-defined infrastructure layer. Or you've defined a common physical layer that you're going to say, hey, minimally every device in the ecosystem must have the following types of things, right? So defining those is very important up front. We have some ideas on what is in each of these layers. We're building out ecosystems on there, like in the service management layer, having that ecosystem of Kubernetes and Docker ecosystem there, and service meshes like Istio is part of that. Understanding where those pieces fit and the strengths and weaknesses of each of the tools in those layers is what we need to continue to work on in our own organizations. Because some tools just may not fit right for what we want, but understanding where they fit in the overall architecture is key. If you have additional questions on this, go ahead and reach out to me at darren.w.pulsipher@intel.com. Check out our blog, check out our podcast for additional information. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.